Hello everyone, welcome to the next class on the MATLAB programming. Today we will discuss the next MATLAB code explanation, that is the Firefly algorithm. Myself Dr. Garg, working in the School of Mathematics, Thapar Institute, India. So you are feel free to contact me through my either of my email IDs, or you can put up a comment on this channel so that I can uh, answer your queries if there is any. So what is the main task of this lecture is I will explain the MATLAB code of the Firefly algorithms with the help of some function is there, but the code is the generalized one. So you can simply replace the fx with your own objective function. Make sure that your objective function or your optimization problem is the unconstrained optimization problem, that is minimization of fx. So look at that, minimization of fx. So make sure that your fx be any one of them. It can be of sin x plus something is there, or based on your objective function, whatever the objective function you have as per your research problem. On the other hand, if your objective function is the constraint optimization problem, like say minimize fx subjective to some constraints, that's why this is called as the constraint optimization problem. So what you can do is you can apply this MATLAB code again on this problem, provided you have to convert this constraint optimization problem into the unconstrained optimization problem with the help of penalty function. So I hope you all knows that based on my previous video how to convert the constraint optimization problem into the unconstrained one. So look at that, my objective function is capital Fx subjective to some constant gx. You want to convert to the fx. So how you convert them? By using this rule, f of x. So this is capital Fx, look at that, fx gx is less than 0. So you have to multiply this with some constant, and that is called as the penalty parameter. And that parameter is a very large number. It can be 10 raised to power 5 or 10 raised to power 7, etc. So once you convert this constraint optimization problem into the unconstrained optimization problem with the help of this, and then you can apply the same uh, MATLAB code that we will see in this couple of slides. So now I just quickly overview about the Firefly algorithm so that it will be easy to create the MATLAB code for this Firefly algorithm. So in the Firefly algorithms, the positions are updated based on this equation. So first of all, what is the notation is that T is my iteration counter. So whenever you are moving from the one iteration to the second iteration, so that's a T plus 1 is there. Xi, what is my Xi is, that is the position of the Firefly. This is the position of Firefly. This is beta 0. This is gamma. So I will explain one by one. So if any Firefly which is located at xj is more attractive than the another Firefly, then xi will move toward the xj. Remember, xi moves toward the xj with the help of this equation. In this equation, what is the alpha 0? Alpha t is the random parameter, lies between 0 and 1. On the other hand, what is the gamma is? I will explain one by one each term. What is the epsilon is? Epsilon is a random number which can be drawn either from the Gaussian distribution, either can be drawn from the uniform distribution, or from the any other distributions are there. So I hope you may remember that the lecture of the cuckoo search where we use the Lewis distribution. If you are using the MATLAB window, then how you write the random number in the Gaussian is you can simply write RANDN. That will give you the normal distribution, normal random number. But if you want to write the uniform distribution function, then you are simply writing the RAND. That will give you a random number between 0 and 1, and that will give you the random number between minus infinity to plus infinity. Now the second, and what is the alpha t is the random parameter which can be defined like this way. Alpha 0, that is the initial randomness. Delta is most probably is defined like this way. T, what is the small t is? This is my iteration counter. So we will set the same alpha t in our MATLAB program. We will see that. So this is the meaning of this. Now what is the beta 0 is the control the attractiveness, and most of them we will set as beta naught as a 1. And based on this alpha naught, L is called as the average scale. We will see is base scale is nothing but my, you can say that is the range. We will define the range in our MATLAB file. So what is the algorithm is that? So we will set the firstly the random number. We will calculate the intensity. Intensity is nothing but my fitness function. Once we are defining the fitness function, then we will update the each Firefly based on this equation. Once we will update this xi, we will check whether this xi will update the fitness value or not. That is, we will perform the greedy selection. What is the greedy selection is? We will update the old xi with this, the calculated xi of t plus 1 at the new equation if it improves the solution. What is the meaning of the improve is, if my objective function is maximization, then we will calculate the objective function at this calculated value and the fitness value at the old value. If this is greater than, then it will improve for the maximization problem. On the other hand, if my problem is minimization, then we will replace this to be a less than sign for the minimization problem. And finally, we will check their termination criteria. If it is satisfied, then we will get the optimal solution. Otherwise, we will move here, and then process is repeated again and again. If you want to find the more detailed description of this Firefly algorithm and how it works, I will suggest you can simply browse this link, or you can simply go through this my channel link. You will find the Firefly algorithms and the working of the Firefly algorithm with this handwritten calculation. The link of these two videos are given in the description. Now look at that, how many parameters are there. One is the population size as usual for all the evolutionary algorithms. Second is the beta naught. Look at that, this is my beta 0. Third one is the gamma. One is the alpha is the random number. Okay, maximum number of the iteration, alpha t. This is my alpha t with respect to the iteration. So this is alpha 0 we needed. And delta we already knows that is any number which are lies between 0.9 to here. So let's quickly start on the MATLAB window. So what you can do is you can simply copy the text from here and put up in your MATLAB file to run them. So I will explain this MATLAB code with the help of this unconstrained optimization problem. You can simply replace this objective function with your own problem. So let's start with them. So that's a, so look at this MATLAB file. I can start with here. So you can simply write format short, clear all and clear screen. So what you can do is you can simply copy this text from here and paste in your MATLAB file. Now you can define the parameters. So look at that, what is the dimension of the problem? There are the two variables. D is my 2. So look at that, I defined D as my 2. What is the LB is? Lower bound. Look at that, the lower bound is -5 plus 5. If my domain are like this way, x1 is this, x2 is my say 9 and x3 is my 11, then first of all, what is the dimension of the problem is 3. How you define the lower bound is x1 is my -2, x2 is my -4, x3 is my 3. Upper bound is that is 7, 9 and 11. So based on this you can define the lower bound and the upper bound. Population size I set as a 20. You can change to be a 520, you can change to be 100. Okay, so that's depending upon you. Alpha 1.0, this is the random, this is alpha 0. Randomness strength, look at that, alpha is my random strength which are lies between 0 1. So that's why this is a highly random, that's a lies between. Beta 0, that is the attractiveness coefficient. Look at that, this is beta 0. Here we define this. Okay, now gamma, absorption coefficient, we will define this gamma as absorption coefficient. You can also change these values are there is no worry. Theta, that is nothing but my delta. Okay, delta lies between 0.95 to the 0.97. So I called this as my theta. So look at that, I consider this as a 0.97. Otherwise you can consider as 10 raised power minus 5 divided by T max means maximum number of the iterations, and the maximum number of iterations I set as 100. So these are the parameters, all these 6 parameters I have defined here. Now what you can do is you can simply copy this text and paste in your MATLAB file. Okay, now the main thing is you firstly define your objective function. So that is the most important task. Since my objective function is this, so you have to create a function. So look at that, I create a function this separately, okay, and call as the fun. So look at that, I call this function as the fun. There are my two dimensions, so I call as the x1, x2, first column, second column, and I can write this x1 square, this is my x1 square, minus x1 x2 plus x2 square plus 2x1 plus 4x2 plus 3 and so on. So this is the objective function I have created here. Now you can save the file with the same name. If you write the name as fun, you have to write the name fun in the same folder where your main program run. Okay, so look at that, if I save this program as, look at that, fun, this is my same function and this is my FA code which I try to make this in this video. So fun and the FA code are in the same folder so that it will not be create any error. So I can copy this text. You can simply do like this way, you can type this one by one from your MATLAB file. Okay, now we will start the initial population. So initial population is a lower limit plus random of u minus L. So you can define like this way, I from the 1 to population size, j from the dimension, POP is called as the population, say. Okay, so this is ij, lower limit, RA and D is a random number, so it's a MATLAB command, upper minus lower. So if I just generate the initial population, if I just run here, so look at that, if I just run the file, so you can see that I will create POP as this. Look at that, these are the random number which are generated as this. Similarly, I set here as population size to be 100. If you want to set as a 10, I can run the file again. So you can see what are the POP. These are the 10 numbers which are lies between minus 5 to plus 5. Now what you can do is, once you will define this population size, then we will define the function evaluation, that is fx. So I use the function as a fun. So fun of POP, we denoted this as fx, that is my objective function. Now we will define this, we will define the scale as absolute value of the upper minus lower, and alpha, this term I call as alpha into theta. So that is reduced by this. So now the Firefly algorithm works based on this. So we will start with the Firefly algorithm main loop. So my task is to here. So let's start with this one. So firstly we will count the iteration from 1 to the maximum iterations. So look at that, how many loops are needed? One is for the xi, one is for the j. It means we need the two loops. One is for the I, for the xi, second is for the xj. Then we will start with the second loop as here. So look at this one by one. So my task is the minimization. So we will define this firstly. So fx is my objective function, fun population of this as fxi. So what is fxi is? This is fi, that is a function value at xi. If I write fj, that is a function value at the point xj. Now this, my problem is minimization. So what you can do is, if the function value at I is less than of the j, it means, but our task is to minimize the function, so it means this is already a minimization, so there is no change in the population size. Else, if the function value is greater than of this, then we will apply this equation. So look at that. In this equation, we need the xi, we need the xj. So how you define the xi? I call as the xi as population of I, xj as population j. Now, what is that next thing? We will calculate r. What is the rij is? This is nothing but my summation of xj minus xi. This, look at that. If you have the 2 points, then you have to use the distance formula. So what is the distance formula between the 2 points of x1, x2, y1, y2? This is x1 minus y1 square plus x2 minus here. So that is called as the Euclidean distance. So how you write that? Look at that. Simple. R is square root, okay, xi minus xj square, or you can write as this xj minus xi square, because it's a square quantity, so there is no problem. So square root summation xi minus xj whole square. So that is calculated as this term. Now since here, so what we do is, now I will calculate this term. So how you calculate this? I call as a beta. This is as a beta 0 multiply e exponential minus gamma of r square. So r square is here. So this is the term, this calculated. Now I can calculate this term. So I call as a firstly step. This is this term I already denoted as a alpha. In you can see I can represented this as already by this. So this is alpha. This is RA and D. So I call as RA and D. What is the 1, 2? Look at the output file. Okay. So if I say D is my 2, so if I call as RA and D 1, 2, so it will generate the 2 random number. On the other hand, if you write simply RA and D, it will generate you 1 random number. Similarly, if I write 1, 3, what is the meaning is first row, 1 row, 3 columns. So it will generate you like this way. On the other hand, if you write like this way 3, 1, it means 3 row, 1 column here. So but I need the value as random minus half multiplied by scale. So how I define the scale is, we already defined the scale as absolute of upper minus lower. So that is here. So now what you do is, now we will calculate x new. Look at that, x new xi plus this term I save as a beta multiply xj minus xi plus this whole term I save as a steps. So this is as the x new. So I can copy this whole text from this code. So I can paste here. Okay. So this is the task. So you can simply copy one by one. So look at that. This is the alpha. So I already defined this alpha here. Scale absolute value of the upper minus lower. So this is the simple task you have to write here. Now what is the main task? So if I just try to run the file, what will happen? If I just try to run, I have to end the 2 loops here. So if I just try to run the file, so if I just, what is the fx I have calculated? Let me check what is the fx I have defined. I forget to define the fx here. So evaluate fitness value. Now look at that. If I just run the file, now if I just look at that, this x new is here. Now, but what is my domain? Look at that. What is my domain is minus 5 to plus 5. So what is the meaning of that? This is the value of the x1. This is the value of the x2, but it lies outside the domain. This is infeasible. So how you check that it's whether it's a feasible or infeasible? You have to define their bounds. So how you define the bound? That is there. Now check the bounds. So how you check that? We will check that whether k is my size. We will check whether if this is greater than of the upper bound. If this holds, then we will set as the equality to be upper bound. Otherwise, we will set as the, if it is less than of the lower bound, we will set as the lower bound. So look at that. If I just try to write this check bound code from here, I can simply write this. Okay, so if I just try to run the file, so look at that, x new, look at that. Now this is -9. Every time when you run the file, it will give you a new value because it's totally a random number are there. So look at that. If I just run the file again here, it will give you here, because POP population is always different. So now you can see that the x new is lies between 0 -5 to +5. Now what you can do, once you are calculating here, we will perform the greedy selection. My problem is minimization. How you perform the greedy? You will calculate the f new and f old. What is the meaning of the f new is? We will calculate the function value at new point. So we will calculate the x new already. So what is the f is fun. Now we will compare this with the old position. So what is the old position is my fx. So if this condition holds, if your problem is maximization, you can replace as a greater than sign. Now if this condition holds, then what we do is we will update the solution. Solution means POP. Okay, so we will update the function value firstly with the f new as a function and the population as this. So this is the greedy selection. Once you are performing the greedy selection, so look at that. If I just copy the text from here, so that will be the end of the Firefly algorithms. So what you can do, the remaining part is, now there are the two loops. You can end the loop for here. You can end the loop for the j loop and end the loop for the I. Now once you will end the loop, so look at that, I just end this one. Then you will run the file again and again. You have to store the value. So how you store the values are there. Memorize the positions. So since my problem is minimization, so I will calculate the minimum value obtained so far. I will save them. So look at that. If I just write this function here, okay, so look at that. If I memorize the best value, what is the meaning of this? Okay, so if I just comment here, so if I run the file, so what is the meaning of this? So fx are here. Which is the minimum value? It's very difficult to find by manually. So if I just write as a minimum fx, it will give you this is the minimum value. So what is the position? What is the position is this is the minimum. So that is my here, that is my third number, but it will not give as a 3. So in order to write 3 also, I have used the two commands. So look at that. If I write here as a HH and GG, any two numbers, minimum of fx, it will give you this value as my minimum value. This GG is my index, so which position is here. So that's the meaning of this. Now I can run the file for the iteration counter. Look at that. This end is for my iteration. I can run the file again and again. So look at that. If I just run the file, then you have to store the best value for the each iteration. If you want to display it, look at that. If I just run the file, so if I just say best fx, so look at that. These are the values which I have obtained after the 100 iterations, but nothing is display on it until unless I have to type fx. Look at that. If I just type again, so nothing is print. So if you want to print the value, so you have to write this command. This is for the show the iteration information. So look at that. If I just copy this, if I paste the text here, now look at that. You can see here, if I just run the file, see what is the meaning of this is, at the first iteration best value is this, after the second iteration, the best value obtained as this, sixth iteration as this, and so on up to the how many iterations I have performed is 100 iterations as this. Now, what is the last phase? Once you will get all the optimal values, all this phase, then you have to plot the results. So look at that. Once I will, how you plot? There is a plot. What is the objective function value is best of the fx, that is optimal value. So I have to plot this. X label I call as the iteration number, Y label as the fitness value, title is my this. So look at that, the graph will be like this way. So once you are here, look at that, X label is iteration number, fitness value, convergence here. So look at that, the graph is decreasing and ultimately it will be stable. So if I just run the file from here so that you are again see how it works. Look at that, if I just run the file, you can see the iteration counters here. That will be give you the optimal graph and will give you the best solution so far. Look at that, the values are, iterations are counted up to the 100 and this is the corresponding graph are there. So if you run again, it will give you the another values are there because it's a random number. So look at that, I again run the file, it will give you the convergence graph are there. Look at that. If I run one more time for you, so what will happen is, if I just run the again, you will see the graph is here. Okay, and it will almost reaches at 6.33. Okay, at each of the run is a minus 6.33. If you see last time again, so look at that, 6.33 is the optimal solution out there. So this is the simple procedure. You can see if you want to look at that, nothing is difficult. You simply just start with the counter. You just replace your objective function. You have to replace only this line with your own objective function and the rest will be calculated the same simplest MATLAB code. Nothing function is used, nothing is there. You have the very simple code. And if you want to compare the performance of this Firefly algorithm, look at the convergence graph with any of the other existing like PSO, ABC, TLBO, social group optimization or the cuckoo search, you can simply click on this link or else go to the description. All the MATLAB code explanations with the same manner is available on my YouTube channel here. If still there is any doubt, you can ask me or you can simply subscribe the channel. You can share the videos with your friend. Till then, happy learning. Best of